Okay, welcome everyone to the presentation of Salinda. He is a master student here in Gothenburg, Knightec West, and worked this year with face detection and face recognition. It's kind of a continuation from the work Alex did last year, but Salinda had the twist that he now went from the Jetson to an Android device. And Android would allow us to be more on mobile devices and also have maybe mobile platforms like cars, for example, that we could support certain features. And yeah, he will now present his results that he achieved, which I think are really nice and really great. So Salinda, please go ahead.
Okay, thanks a lot, Andre. And first of all, I should thank Knightec for giving me this opportunity to conduct the thesis project. And also, again, thank you very much, Alex and Andre, for being my supervisors and all the guidance. Yeah, as described, we explored on how face recognition can be done on Android devices. Yeah, a little bit background. Mobile devices are getting popular these days, as described by Andre. And also this machine learning thing come into these edge devices heavily. They try to avoid sort of involvement in the network. And hardware capabilities are booming, so they try machine learning edge devices. So no exception for face detection and recognition. It's very heavily used area in like security domain and other application areas. So it's worth course to explore about. Yeah, but what's the problem? Since there are many models and things have developed over the years and proposed by researchers on specifically designed for mobile area, so it's difficult to select which one is good and which one is bad. So every paper suggests different results. Some results may be biased to their solution, and we never know until we try out. So that's the problem we tackled, and the solution is simple. We thought of doing a analysis, independent experiments, and select a model based on the results. Yeah, that's what's all about this project. So I will explain the methodology as a typical project, how I approach to solve this. So we did a literature study. So we explore more about what are the existing solutions and what are the theories goes behind, what have they evolved over the years. And then we select a few promising solutions that worth to try out. And yeah, that's the next step. And sort of implemented them in the experimental level. After that, we use a data set to evaluate different criteria of the models, and then select what are the good models that to be go forward. And also we developed one application to sort of face recognition application that can be used as a starting point in whatever the projects the company might take over in future. Yes, so all these things I focused on writing the report as well, part by part. Yeah, that's how this whole project was carried out. The literature study mainly focused on two areas, face detection and face recognition, targeted on mobile environment. So we tried out what are the good models for face detection and same for face recognition. And also learned few theories goes behind which make these models are good ones as they claim. So for example, like single shot detection, it's something really good enhancement in the world of face detection. So after having this detection, they claim that the efficiency of detection models has tremendously improved. Earlier it was very slow, and with this technique they have gained a lot of enhancements. I'm not going to explain everything, so it's very complex matters. In terms of recognition models, where that we extract a feature vector that describes the image. This inception module and residual networks have played a good role. So they in combination itself made a class of networks called inception ResNet. And also this depth-wise separable convolution. That's a very good enhancement to the convolution neural networks. You all know that we use convolution neural networks to perform these visual tasks. But when it comes to the mobile environment, one of the key things is number of operations that needs, specifically talking about multiplication operation. That's kind of heavy in computational cost. So these researchers have put an effort to reduce number of multiplication operations. So that's how this depth-wise separable convolution came into picture. Yeah, it's kind of complex to explain. I'm not going into detail, but it's a nice technique, and it has given tremendous improvements. Also, that's on more theoretical aspects. We explored on what are the possible frameworks to develop. There are a few frameworks as well, which we could use to develop, basically implement a model in a mobile device. I'll present in the next slide. Yeah, so these are the findings, and these are the models that we picked to go ahead, basically to experiment with, like SSD ResNet, this famous model for face detection, and Google MLKit. So both of these solutions are developed on the concept that I explained, this single shot detection. Google Kit is kind of more enhancement to the SSD ResNet. Yeah, that's on detection side. On the recognition side, we found FaceNet, a model developed by Google to do the face recognition, to identify a face. And
excuse me, is it only me, but I can only see the first picture from the presentation. If you have switch slide, I can't see it.
Yes, I do see a first slide.
I'm really sorry. What is the problem then? How about now? Can you see a different slide?
Yes, now you are on the problem slide for us.
Does you observe any change?
Yeah, now you are on the third slide.
Okay. I'm really sorry. Maybe a technical issue.
A quick question. I don't know. I don't see really a presentation mode. It looks like more like the preview, but I'm not sure. It could be the program you're using. So I'm not really.
How about now?
I see the problem. I see your mouse moving. You're clicking through the slides. It works, but yeah. But if it doesn't seem to be in presentation mode, that is what I wondered if it's.
Yeah. This is the way to go presentation mode. How about now? It's still not in like a presentation mode?
It's still the same window, just that the play button is grayed out. So.
Oh.
I don't know if you have two screens. And it presents on the wrong screen.
How to solve this thing? Let me share it again. Yeah.
Yeah, that looks like it should be now.
Does it change now?
Yeah, looks great.
Oh, I'm very sorry. Yeah, this is what I've been talking about, like describe the problem, solution, methodology, and yeah, basically in textual context, that's what I talked about. Where I was actually, yeah, here. Yeah. So this is the outcome from the literature study. Came up with the 2 models on face detection and face recognition. We picked up 3 models like FaceNet developed by Google and mobile FaceNet developed by Chinese research group. They claim it's an enhancement on FaceNet, and this Inception ResNet, it's kind of heavily used face recognition model, especially I think Alex used in his experiment in last year. So yeah. So these are the frameworks that we use. We use OpenCV Android to develop a detection application with the use of cafe model. So it gives good API to load different models inside the mobile. And of course, TensorFlow Lite, as its name suggests, is the mobile version of the TensorFlow framework. There we can also convert any model to a special format, of course, TF Lite format, and then use in this mobile framework. And similarly, PyTorch Mobile is the mobile version of PyTorch. And there also, you have to simply convert any model that developed through PyTorch to a special format, Torch script, and then we can use it inside the mobile. All are developed on Java-based an Android platform. Yeah. Yeah, for our experiments, we decided to go with pre-trained models and then try to implement everything from the scratch, because a lot of people have tried these things previously in individual efforts. Yeah, I will explain particular experimental flow that I used to conduct this experiment. I thought of it's worth sharing. So for example, image would be first read. This could be a camera frame or a photo saved inside your phone. And then apply the detection algorithm, whatever it is, and select the face. It simply provides a few coordinates, and we need to crop that part and resize that face part according to the face recognition model. Different recognition model require different dimensions in terms of their input, so we need to adjust it accordingly. And then the recognition model will produce just an array of numbers, which we call the feature map, feature vector, or the embedding. And also we together tag the name, which we extract from the image file, or in other mechanism we provide through an input. Yeah, this is sort of a record that we maintain as a training record. And in the database, we'll assume we have few records as we put like training instance, and then we match against one of them. And then we pick the prediction and compare with our target record, is it correct or not. So in typical flow, I pick what are the wrong predictions and counted them, and also meanwhile take some measurements on the time taken to predict and also detect, and I save them inside a file of the mobile phone to be analyzed later. That's a typical flow done in the experimental stage. But later, develop this application to access the camera and do the same task. For example, in this diagram, you can see 3 main flows basically. One to detect the faces, and in the detection it will highlight the face part and present to the user. Then user need to add it to the database by clicking and entering a name. Then it will go through the recognition and stored in the phone. And there's another mode just to recognize faces. there it detect and recognize, perform both tasks. These are the highlighted in 3 different colors, mainly the orange, blue, and pink. Yes, I added few screens from the application. So, for example, this is the detection mode. It just simply detect the face and doesn't do anything. And then we need to add it to the database. Okay, giving a name. This is this and that. And later, in the recognition mode, take the same picture. It do the correct predictions with some value. That's the distance of this particular image to the training record inside the mobile already. So yes, this is it. Yeah. So now we come to the evaluation. So these are the criteria that evaluated. For example, for the face detection, we were mainly considering the detection time. Most honestly didn't evaluate the accuracy, because pretty much face detection was pretty much accurate. If there's a face, definitely detected. The main concern was detection time in that case. In the recognition, we evaluated the accuracy and the inference time. That means the time taken that particular model to generate output of the image, feature vector. And then the prediction time. That's basically going through the training records and predict. You can say time taken to do the classification. And also in general, evaluate, observe the memory and CPU usage as well. Well, the data set we use for this is labeled Faces in the Wild. It's a very famous data set among researchers, especially used when benchmarking models like this. And also we use one-shot learning method to do the prediction. Like I explained below, in the training phase, we send the image through the model and store. And then in the testing phase, we send another image and get the feature vector and then compare the distances to find the nearest neighbor, something like that. And also, I sort of use this cross-validation technique to get a better understanding about the kind of, how to say, very reasonable figure on the accuracy. So we have a limited set of data in place. So I want to try each of them in as training data and testing data. So for example, something like this. So if you use particular data set like one-shot 200, that means 200 classes, 200 different people will be trained, and for each class only one image is used. And likewise, there are few parts similarly. Like for example, if you take Alice, we have one set with Alice starting from 1, Bob 1, Carl 1, and then similarly different page of the same person. So each set contains exactly 200 images of those 2 classes. So one set used as a training data and the rest used for testing, and in the next iteration part 2 used as the training and the rest used for testing. It's like that. So for all the iteration we measured the accuracy and get get average value. Yeah, well, yeah, I forgot one slide. I think we use kind of in similar way 4 different data sets like one-shot 200, 400, 600, and 800. The idea was to give more new data and see how the models are behaving, to expose more new data. That's the idea. And also same time, we can increase the set of training records and see the performance, especially the latency. Yes. Well, now coming to the results, first talk about the results of the detection algorithms. It was clearly, obviously, Google ML Kit was performing better, and it only took around 67 milliseconds to detect a phase. And I conducted this experiment with using 1 phase and 3 phases. That means in a particular image, there will be 3 phases, just to see whether there are any performance degradation. But honestly, didn't notice any. I mean, it seemed like number of phases doesn't matter for the model. Yeah, it's clearly Google ML Kit was doing well. Since it scored such a low value, I didn't try to explore another model. Yeah, maybe later. We go ahead with the Google ML Kit for the rest of the experiments. So that's in detection. I'll come to basically recognition area. So this is the accuracy values from 3 different models that we evaluated: FaceNet, mobile FaceNet, and Inception ResNet. Yeah, FaceNet was the one always recorded high accuracy, and it slightly degraded its accuracy when the new data was introduced. Whereas mobile FaceNet was the second place, and Inception ResNet kind of recorded low accuracy, especially when I give like 100 data and for training and more data to test it. Yeah, this is the test accuracy basically. Yeah, then I recorded the training accuracy as well and compare. I wanted to see the difference between training and test accuracy. So again, the FaceNet did a great job. Like it's when increasing the data, the difference didn't change much. Whereas you can see in the Inception ResNet, it recorded train accuracy almost like 100, but the test accuracy was drastically decreasing when increased the data. Yeah, this is on accuracy part. Yeah, then we measured inference time that the model take to generate the output. So it's directly based on the model architecture. Yeah, in that sense, mobile FaceNet was doing very good. It only took around nearly like 100 milliseconds, and FaceNet took around 180 milliseconds in almost all the cases. And Inception ResNet was taking more than that. So you can see all 3 are in one diagram. For example, like 1,800 measurements were taken to obtain this graph, and it gives some reasonable value to these figures that are obtained. They are pretty much on the line. Yes. Also, I measured the prediction time that basically measuring the performance of the classifier we developed to find the prediction. Yeah. Again, mobile FaceNet was in the front line. It only took 3 milliseconds. I mean, I was also quite curious, but took several measurements, like to go through 800 images and predict one prediction. But for the others, it took around 6-7 milliseconds. So this is merely based on the size of the output of each of these models. And for mobile FaceNet, it's kind of low, like 120 output values. in the feature vector. Like the other two, it's more than that, like around 300 something, as I can remember. So it clearly explains this difference. But the good thing is it's not exponentially increasing when increasing the number of records in the training data set. Yeah, I observed the memory and CPU usage as well, but for all these three, it didn't grow like tremendously. They were kind of in the reasonable margin, like 400 to 500 megabytes usage of memory. I took this measurement by giving a kind of high load, I trained with 1,000 images and also run another 1,000 to test, 1,000 images to test. So wanted to get the maximum value of the memory usage and CPU usage. This pattern was observed in every case. Like in the initial phase, it kind of go high and then slowly degrading and kind of stable value. So it's continuously recognizing images, reading from the phone, yeah, one after the other. Yeah. So those are the basically summary of the results I obtained with this experiment. So in conclusion, yeah, I would recommend to go ahead with Google MLKit without a doubt. It's very fast and accurate. In terms of face recognition, FaceNet seems to be the most accurate one. In my opinion, I think I put more weight on the accuracy when it comes to face recognition. So recommend to go with FaceNet. And after I implemented this in the real camera, it gives some decent user experience, of course, even though its recognition time was around 180 milliseconds. We could achieve like 20 frames per second because you can, with the threads and stuff, we can improve the performance of the program. So yeah, yeah, that's the conclusion. Yeah, that's pretty much it.
Salinda?
Yeah.
Are there any questions from anyone?
Yeah, I have a question for you, Salinda.
Yeah.
First of all, great presentation. Well done. It was really nice to hear how you have done the work. And then interesting results as well in order when you tested the Inception ResNet and FaceNet and MobileNet. But my question is, which version did you use in order for the Inception ResNet? Because it is version 1 and version 2.
Yeah, that's something. It was Inception ResNet version 1. Okay. Because I took it from the PyTorch mobile pre-trained set. I tried to get to V3 or V2, but it wasn't available. Yeah, maybe V3 would give much better results than this.
Exactly. Yeah, well done. Actually, I have one more question for you, Salinda.
Yeah.
What do you think was the most fun part in the project?
I think for me, actually, the experiment part was the fun part rather than developing, because then you see these patterns, how these things are changing when you increase the number of images, and for example, these graphs, how they are tend to converge around some values, like in terms of, for example, this one. So yeah, I observed different graphs when we increase the measurement and to get some idea. Yes, yeah, this experiment part is the one. Of course, if I had some time, I would love to use another data set and see whether I get the same results or not. Yeah.
And the hardest part, which was the hardest part in the project?
Yeah, I think the first part, to hang around, to read the literature and to decide which one to pick, to kind of to build up your context. I think that's the most difficult part. But over a few weeks, when you live in this context and reading about the papers and shifting back here and there, then you sort of develop, okay, these are the things that the people have revolved around most of the time. So it would be a great idea to go with these options and try. Yeah, so deciding these things was the difficult, I think, I guess. Yeah. Of course, some elements come to implementing. It's a lot of like configurations and environment problems, especially to hang around with this Android thing. It gives various new errors sometimes. Yeah.
Yeah, you're well done. Very good.
Thank you.
Okay. I think we also will not get much more questions. Some people left already the presentation. I just want to say again, great work, Salinda, nice presentation. I had the advantage also that I could read the thesis already, so I have a bit more knowledge. But I think it was very well done. The work was really nice. And I mean, that you had a nicely working prototype is also just a cherry on the cake, basically. So I would close the meeting, or at least the recording here, and thank you very much for the presentation.
Thank you again for participating, and sorry for the technical